A certain flight arrives on time 90% of the time, and suppose 115 flights are randomly selected. We're going to answer these following questions by using a normal distribution to approximate what is really a binomial experiment. So for starters, part A asks for, of the 115 flights that are randomly selected, what's the probability that 98 are on time exactly? So what we're going to do is open up StatCrunch, and this could be answered by using a binomial distribution. So like in calculators, there's this thing called binomial, but it's specifically telling us to use a normal distribution to approximate the answers instead. So I'm going to choose normal. So, this thing here. To use this calculator to answer part A, you have to have a mean and a standard deviation. So to go over how to get those, I'm going to pull up my calculator. The value of the mean, so if flights arrive on time 90% of the time, and there's a total of 115 flights that are randomly selected, 90% times 115 should be what the mean is equal to. So that formula was n times p. So in my calculator, I'm going to take 115. I'm going to multiply it by 90%, which is 0.9, and I get 103.5. So that's the value of my mean. Again, if you're going to use this calculator, you have to have a value of the mean, and it's this probability times this value of n. We also need a standard deviation. The formula for this was, you take n times p times 1 minus p, and then you take the square root of that value. So a slightly more complicated formula, but p is going to be 0.9, 1 minus 0.9 is going to be 0.1, so I'm going to do 115 times 0.9 times 1 minus 0.9, which is 0.1, and I get this value here, 10.35. But the formula says to take the square root of this value, and here it is. This is the standard deviation if we want to use the normal distribution to approximate this binomial experiment. It doesn't say how many decimals to round to, but I guess just to be safe, maybe I'll go out 1, 2, 3, 4, maybe out to here, maybe 6 places to this 1, which will get rounded up to a 2. So the more that you enter, the more accurate your answer is going to be. So 3.21714 in this case. We don't need the calculator anymore for this problem, so this is how we start. Okay, the next thing is, this idea of exactly 98 flights are on time. Now, how do we enter that into this distribution once we have the mean and the standard deviation? We're going to have to use the between mode for this calculator. Now, if I just went ahead and put in 98 for both, this would be one way you could perceive saying exactly 98 if you start and stop at the same number. But if you click compute, it tells you 0, and that, can't be the answer. So if you recall, when we approximated a binomial experiment on a normal calculator, we went up by a half and down by a half to these two numbers. Otherwise, if you don't do that, you're going to get an answer of 0 for all these probabilities, which can't be the case. That being said, you want to include 98, so you have to go a little bit above it. So I'm going to add 0.5 on this side. On the lower side, I'm going to subtract 0.5, which will drop it down to 97.5. So if I click compute this time, so right in the middle here is 98, and by going a half on both sides of it, you're surrounding the value of 98, and you actually get a probability that makes sense for this problem. It's asking us to round to 4 decimal places, so that's out to this 9. It'll get rounded up, that 8 goes to a 9, that 9 goes to a 0. So my answer is going to be 0.0290. Okay, so the idea is not only are we using a normal calculator, therefore we have to come up with a mean and a standard deviation. When we actually determine these probabilities, we have to be a little bit careful to make sure we go up or down by a half as necessary. For the next part of this question, for part B, it says, well, what's the probability that we're, not just equal to 98, but, more than 98 of the flights arrive on time? So for this, we're going to switch it back to our standard mode. And we want the value of x to be greater than, and the value that you would think you'd put here is 98. And you'd click compute. But technically, this answer is going to be wrong. And the reason is you want to make sure that you're including the value at 98, which is currently here. So in doing so, you want to go down by a half to make sure you do actually overlap the location right here. So what I'm going to do is subtract 0.5 from 98, which gives me 97.5. Okay, so this is going to be the probability that we're looking for. Again, we're rounding this to 4 decimal places. So the answer is going to be 0.9689. Okay, I think the remaining part's really similar, but let's just go through it. Okay, I'm noticing that the second one here had an equal sign, and this one does not. Okay, so we want less than. So I want to switch this to less than, but I'm seeing that there's an equal sign on this, and this does not have an equal sign. So let's say you put in the value of 110. As it stands, this answer is going to be off a little bit because here's 110, and you want to make sure that you're actually not including anything around 110. So you wouldn't want to go up above it by 0.5. You would actually want to go down by 0.5 to make sure you're not including 110 or even a little bit of the area around it. All that being said, I'm going to take 110 and subtract 0.5 to 109.5, and I'll click compute. So I get this value here. Again, it's asking me to round to 4 decimal places, so that's 0.9689. And for the last part here, what's the probability that between 110 and 111 flights arrive on time? So for this last part, we're going to have to go back to the between mode in the calculator. So for all of these, I'm starting just by entering in the numbers that appear here, 110 and then 111. And I'm clicking compute, and I'm just stating that, well, you want to include 110 and 111. So this answer as it currently stands is probably not going to be right. At 111, you want to go over a little bit by 0.5 to make sure you're actually including that value. So here at 111, I'll add a 0.5 to it. But at the same time, if you click compute, it's currently set up so you might be missing 110. So you want to go down below it a little bit by 0.5, which is 109.5. And the value rounded out to 4 decimal places is going to be this thing here, 0.0246. Okay, so that was everything for this question. Technically, it was a binomial probability experiment, but what we're doing is using a normal distribution to actually approximate these values.